Welcome students. So let's move on to the second part of the question. So what is the second part of the question? It is asking to find out the maximum concentrated load applied at a distance of 2 meter from one end of the beam which the beam can easily carry. Okay, so I have already drawn the beam. This is my line representation of the beam, and on this beam a load P is acting at a distance of 2 meter from the left support. Okay, the span of the beam is already given, and the maximum bending moment we have already calculated in the previous portion, which is equal to 15625,000 Newton millimeter. Okay, so what we have to do is we have to find out the maximum load P that is acting at a distance 2 meter with respect to this maximum bending moment. Okay, in order to do that, what we have to do, we have to find the location at which the maximum bending moment will occur. And in order to find the location at which the maximum bending moment occurs, we have to first find out the support reactions. Okay, then after finding out the support reactions, we will draw the shear force diagram, and from the shear force diagram we will try to calculate or try to find out the location at which the maximum bending moment occurs. Okay, so in order to find out the support reactions, we will employ our very favorite three equilibrium equations, that is summation of moment equal to 0, summation of vertical reactions is equal to 0 or vertical force is equal to 0, and summation of horizontal forces is equal to 0. Okay, so since on this beam no horizontal force or reaction is acting, this can be omitted. Okay, this equilibrium equation can be omitted, and we can find out the rest with the help of these two equations. So first we are taking the summation of moment about point A. Suppose this left support is point A and the right support is point B. So we are taking the summation of moment about this point A as 0. So if we fix this support and then suppose this is the beam, the load P is trying to rotate the beam in the clockwise direction. Okay, so we are taking clockwise rotation as positive, and the moment due to this P will be equal to P into 2, because P is the force and the perpendicular distance from the left support is 2. So moment is nothing but force into perpendicular distance minus. Now we have this RB. Okay, this RB is the support reaction, and this RB is trying to rotate the beam in the anti-clockwise direction. Okay, it is trying to rotate the beam in this anti-clockwise direction about point A. So the moment will be negative, and what is the distance of RB from A? It is 5 meters, so RB into 5. So from this expression we will be able to calculate RB, which is equal to 2P by 5. Next we are implementing the second equilibrium equation, okay, which states that summation of all the vertical forces is equal to 0. So what are the vertical forces available in this beam? It is RA, RB and this P. Okay, so RA plus RB will be equal to the downward load, which is equal to P. That is what I have written here. So from there we will be able to calculate the value of RA, which is equal to 3P by 5. Okay, so RA is equal to 3P by 5 and RB is equal to twice P by 5. Now, in order to find out the maximum bending moment or the location of maximum bending moment, we will draw the shear force diagram. Okay, so how do we draw the shear force diagram? We have all the values of reactions here. We have the value of load here. So this is a line which represents the axis of the beam, the original position of the beam, and with respect to this axis we will find out the different magnitudes of the shear force, and simultaneously we will draw the shear force diagram. So first at this point A we have the value of reaction at A as 3P by 5. So what we are going to do, we are going to raise the magnitude of the shear force from 0 to 3p by 5. Okay, we will draw this line. Then along this length of the beam, before load P acts on the beam, the value or the magnitude of shear force, that is 3p by 5, remains constant. So the line here is a straight line, since the load is constant or the shear force is constant along this span of the beam. And when we are coming to this point, suppose this point is C, we have a downward force P acting. So previously the shear force was acting upwards, means it was a positive force, and now P is a downward force. So again, so what will happen? My shear force will decrease. By how much will it decrease? It will decrease by P amount. Okay, so if we subtract P from 3p by 5, my value is going to be minus 2p by 5. So I am again reducing this value of shear force from 3p by 5 to minus 2p by 5. And what happens? It crosses the axis of the beam and comes below the axis of the beam, so that it becomes a negative value, that is this 2p by 5. Again, throughout this span of the beam, the value 2p by 5 remains constant, and when we are reaching B, we have again an upward reaction, that is 2p by 5. So this 2p by 5 gets nullified and the magnitude meets the axis of the beam. Okay, now see, what will be my location of maximum bending moment? The location of my maximum bending moment is going to be the point at which the shear force is changing its sign. So along which location does the shear force changes its sign? Along this, in this section, the shear force is changing its direction from positive to negative. So this is going to be my point where maximum bending moment will occur, which is at a distance of 2 meter from left support. So now what we are going to do, we will simply frame an expression for bending moment at a section X. Suppose this is my section X, alright, and the bending moment at this section X will be given by, see over here, I've written it already. The bending moment expression is given as RA into X. Since this is my RA and this is X, X is the perpendicular distance from RA with respect to this section. So we are putting the values of X as 0 and bending moment will be equal to 0. Okay, at this point A. And again, in order to find out the maximum value of bending moment, we are substituting the value of 2 meter in X. So if we substitute 2 in this expression, RA into X, we will get 6p by 5. So students, this value 6p by 5 is the value of my maximum bending moment when a load P is acting at a distance of 2 meter from left support. So we have already found out the expression for maximum bending moment, the value, okay, the exact value. We will simply substitute this value with 6p by 5. So 6p by 5 is equal to 15625,000, and if we equate it for P will be equal to 13.02 kilonewton. So this is how the procedure for calculating the different types of loads. We have to simply find the value of maximum bending moment, and with the help of equilibrium equations, with the help of shear force diagram and bending moment diagram, we will find out the maximum values of moment and equate it with our maximum bending moment value. Okay, so that's it for today. Next day we are going to start shear stresses in beams. Thank you everyone.